Thank you for clicking on that thumbnail and watching this video. This is the solution video of paper 41, summer 2022, Cambridge AS level mechanics 1. Question number 1. A car starts from rest, that means initial velocity is 0 meters per second, moves in a straight line, okay, with a constant acceleration. So acceleration is constant. In mechanics, whenever you read one sentence, always try to figure out what it means, okay? So constant acceleration means we can use the 4 kinematic equations which are given in the formula sheet in the exams. For a distance of 200 meters, so 200 meters is the distance from here till here, reaching a speed of 25 meters per second, 25 meters per second, all right? The car then travels at this speed. This means 25 meters per second. So it continues for 400 meters. That means this velocity is maintained. That means acceleration is 0 in this case. Here it was constant. Here it is 0. Before decelerating, now there is a stage 3 for this where acceleration is negative. Uniformly, constant deceleration again to rest. That means finally it is, for this stage 3, V is 0 meters per second over a period of 5 seconds. So time here is 5 seconds. So I have visualized this. Find the time for which the car is accelerating. So they are talking about this first part. Okay. To find time, we may use this V equal to U plus 80, V is 25, U is 0, acceleration and time both are not known. That means we have to find acceleration first to find time. For finding acceleration, we can write V square equal to U square plus 2AS. So 25 square equal to 0 square plus 2 times A, and we know the distance 200 meters, yeah? So 625 equal to 400 A. Okay, so A will be 625 divided by, which comes out to be 1.5625. And now we can use it here. 25 equal to 1.5625 T, and the time will be 25 divided by 1.5625. That comes out to be 16 seconds. Okay, next part. Sketch the velocity time graph for the motion of the car. Okay, for that I'll need a vertical line. Okay, so this is T for me, this is V, velocity. So in first phase, first stage, it started at 0 meters per second. Here the initial velocity was 0 meter per second, and then it reached 25 meters per second. So let's say that 25 is here, because this velocity in meters per second. So it started with 0, and 16 seconds later, so let's say 16 is here, 16 seconds later it reached at 25 meters per second here. Okay, I will join it later. And then next, for some time, for how much, for next 400 meters, it maintained that speed. Since acceleration is 0, we can simply use time equal to distance, in this case, over speed, because it's straight line, constant speed. So 400 divided by 25, yes, the speed maintained is 25, which is again 16 seconds. So we have to maintain this distance till here, which is again exactly same time, 16 seconds. So it becomes 32 seconds now, 16 plus 16 more. And finally they said in 5 seconds, yeah, in 5 seconds it comes to rest. So we will just add 5 seconds to it, say here 37, it comes to rest, and now I will join this. So done. Sketch the velocity time graph for the motion of the car showing the key points. So these are the key points. Here it is 0, 0. This point is 16, 25. This is 32, 25. And finally, okay, it is wrong. We'll have to, okay, adjust it. This is the VT graph. Okay. See, find the average speed, not velocity. Since it is speed will be equal to total distance traveled divided by the time it took. And we already know the time. Time is how much? 37 seconds, right? So we know the denominator. Only the numerator we have to see. How much distance was traveled in the first stage? 200 meters. As far as I remember, 200 meters. Yes, 200 meters. Then 400 meters. But third we don't know. Okay, third is the challenge, and there's no problem. We can find the area of this VT graph in this one and we'll get the distance. So area of triangle equal to half base times height. So in VT graph, if we find the area under the graph, it gives us distance. So this is the only one we need, others we know already. Half base, how much is base here? 5. How much is the height? 25. That is the y coordinate here. 25 times 5, 125 divided by 2 is 62.5 meters. So we know the third one also. So 200 plus 400 plus 62.5 now. Total distance is that one. So 662.5 over 37. And now we can find average speed, which is 17.9054 with 3 significant figures, 17.9 meters per second. This is the average speed. Okay. Two particles, P and Q, of mass 0.5 kg and 0.3 kg respectively are connected by a light inextensible string. Okay, the string is taut and P is vertically above Q. P is, let me draw here, P is vertically above Q. So this is Q and this is the line that is connecting them. P is 0.5 kg and Q is 0.3 kg. The string between them is taut. Okay, a force of 10 Newton is applied to P vertically upwards. Okay, so there is a force of 10 newtons on P upwards. Find the acceleration of the particles and the tension in the string. Two things we have to find out. So let's focus on, there will be tension here. So this will be tension and tension. So let's focus here. At this point, what will be the free body diagram for this one? Let me draw here. T is upwards and there is a force downwards, which is the weight of this 0.3 kg, and we multiplied by 10. So 3 Newton is the weight of this, and this system is moving. As a result of what? T will become the applied force. We know that MA equal to applied force minus resistive force. So M, mass of this particle, I'm focusing on only this, okay, 0.3 acceleration they are asking us to find. Applied force in this case becomes T minus resistive force will be 3 Newton, which is trying to stop it. So we want to find acceleration first. That means T should be isolated so that it is eliminated. So 0.3a plus 3 is equal to T. This is equation number 1. Now let's focus on this part. So free body diagram for that will be 10 Newton upwards. There will be tension downwards, and additionally there will be the weight of this particle 5 newtons. So this gives us, by using the same, it will be 0.5 A equal to applied force. There are two applied, no, it is going up, right? So 10 Newton minus, these two are trying to stop it. So minus T minus 5, both of them will be negative. So T, I have to isolate T, so T comes to the left side. What do we get here? 10 positive minus 5 minus 0.5 A. So 10 minus 5 is 5. So T equal to 5 minus 0.5 A. Equation number 2. Both are in terms of T. We can equate the other sides of T. So equating equation 1 and 2. What do we get? 0.3A plus 3 is equal to 5 minus 0.5A. Now we'll collect A's on one side and we'll get our acceleration. So 0.3A plus 0.5A equal to 5 minus 3. 0.8A equal to 2. A will be 2 divided by 0.8, which is a 2.5 meters per second square. We found the acceleration. What about the tension? So we can use any one of the equations. Let me use this one. So T equal to 5 minus 0.5, acceleration is 2.5, which is 5 minus 1.25, which is T is equal to 3.75 newtons. Got both of them. Alrighty, question number 3. A crate of mass 300 kg is at rest. So U is 0 on a rough horizontal ground. Alright. The coefficient of friction between the crate and the ground is 0.5. So mu is 0.5. A force of magnitude x Newton acting at an angle of alpha above horizontal is applied. Above. So this is above, this is horizontal, so this is angle alpha and this is x newtons. Acting, okay, is applied at the crate where sine alpha is 0.28. Sine alpha is 0.28. So we can find alpha in this case, right? Okay, let's find alpha equal to sine inverse 0.28. And let's not evaluate it. One we need, we will do it. Find the greatest value of x for which the crate remains at rest. The motion of the crate should have been in this direction. That means there is something which is trying to stop it, and that will be the friction. Mu r is the frictional force which will stop it, which will not let it move. They're saying greatest, and the greatest force will be when this is in the opposite direction. It cannot, because it's a horizontal surface, so it cannot be on the right side. So for equilibrium, mu r has to be equal to, what is the component of x in this direction? X cos alpha. Wherever is the angle between the actual force and the component, we make it cos. So there will be a component in this direction also, x sine alpha. What else is vertical? Is its weight. What is the mass? Is 300 kg. So 3000 newtons is the weight, and there will be a reaction force which is upwards. Okay, so we said mu r is equal to x cos alpha. What are they saying? Greatest value of x. We have to find greatest value of x. First, let's find cos alpha because we know sine alpha. So cos alpha will be cos sine inverse 0.28. Yeah, this is the value of alpha. Use your calculator to find it. And cos alpha comes out to be 0.96296. I've tried to take as many digits as possible. So what is left now? Mu we know 0.5. R we don't know. So let's find R. In vertical forces, R plus x sine alpha will be equal to 3000 newtons, right? Because we don't want any motion in vertical direction as well. So R, which we need to use here, will be 3000 minus x sine alpha, and sine alpha they've given is 0.28. This is what we will use here. So 0.5, 3000 minus 0.28x is equal to, let's call it 0.96. 0.96x. Alright, let's open the bracket. 1500, yeah, 0.5 times 3000 minus 0.5 times 0.8 will be 0.14 equal to 0.96x. So 1500 equal to 0.96x plus 0.14x. Okay, so 1500 equal to, it will be 1.1 x. Yeah, divide both sides by 1.1, which is 1363.636363. So rounded off to 3 significant figures, 1360 newtons. That is the greatest force. Okay. Again, the question is about force. Okay. The three coplanar forces of magnitude 20, 100 F, we can see here, act at a point. The directions of these forces are shown. Okay. Given that the three forces are in equilibrium, they are equal in all sides. That's what it means. Find F and alpha. Okay. So let's write their components first. Just like previous question, wherever is the angle becomes cos. So this direction, the component of F will be F cos alpha. On the opposite side, it will be F sine alpha. Similarly, this will be 20 cos 40. And we will have plus 20 sine 40. This one will be 100 cos 20, and we'll have here 100 sine 20 degrees. Okay, all of them done. Now we'll make equations in vertical and horizontal directions. Let's say vertical direction, this one. So it has to be in equilibrium. That means this 100 cos 20 has to be equal to the other two sides. So 100 cos 20 will be equal to 20 sine 40 plus F sine alpha. Let's keep F sine alpha on this side, but bring this to the left side because we know that both of them are numbers. Cos 20 minus 20 sine 40. So F sine alpha will be equal to how much? If I evaluate this one, it comes out to be 93.9692 minus this will be 12.8556. So F sine alpha is this minus this, which comes out to be 81.1345. 5. Let's keep these many digits so that it gives us more accurate answer. Now we have to equate the horizontal ones. So in this case, f cos alpha, which is this way, will be equal to the sum of these two which are on right side. So equal to 20 cos 40 plus 100 sine 20. So f cos alpha equal to 15.321 plus of 34.20. I have ignored the digits after this. My final answer will be in terms of 1 or 2 digits, but I'll keep most of the digits here. F cos alpha is 49.5221. Okay, so now we got two equations. This is equation number 2. First we got equation number 1. What common thing you see here? F is the common part. So if I divide this equation number 1 by equation number 2, you will see that f sine alpha divided by f cos alpha, f will cancel out, and that will make the job easy. So f sine alpha over f cos alpha, left divided by left, so right divided by right. 81.1345 divided by 49.5221. F and f cancel, and sine and cos become tan. So always divide sine by cos, not cos by sine. Okay. So if I would have done something sine here, so this would be divided by the other one. That is tan alpha equal to 81.1345 over 49.5221. So alpha is tan inverse of same, 81.345 over 49.5221. When I use my calculator, alpha comes out to be 58.600. So 58.6 degrees is this angle alpha. Is there any B part? No. That means that's what we have to write. This is the answer. They're also saying find f, and we can use, let's use this one. So f will be 49.5221 divided by cos alpha. And alpha is known to us now, cos 58.60 comes out to be 95.0503, we can see, and rounded off to 3 significant figures, 95.1 Newton. Alright, let's go to the next part. Two racing cars A and B are at rest, okay, alongside each other. So this is car A and this is car B at point O. So the point where they start is point O. On a straight horizontal test track, the mass of A is 1200 kg. The engine of A produces a driving force of 4500 Newton. That's the applied force. When A arrives at point P, that means there is some point P somewhere. The speed is 25 meters per second. Okay. The distance OP is d meters. Obviously they will be asking us to find d. The work done against the resistance force is experienced by A between O and P. Total resistance is 75,000 joules. Okay. In total distance, 75,000 work was done against the resistance. Show that D is 100. Okay. So we can use the energy formula in this. That means work done by applied force is equal to work done against resistive force plus change in kinetic energy plus change in potential energy. Yeah. Work done by applied force. We know the force here, 4500. So 4500 force times distance d, this distance it traveled, right? That is the work done by, total work done by applied force. Work done against resistive force is 75,000 joules. The difference in kinetic energy, let me do it here. The formula for difference in kinetic energy is half m final velocity minus initial velocity. In this case, it will be half, mass is 1200, final velocity is 25, initial was 0. So it comes out to be 600 multiplied by 25 square, which is 625. 600 times 625 will be 375,000. There is no change in potential energy because they say it's a horizontal track. Horizontal track, that means the height did not change. If did not change, the change in potential energy is 0. So this gives us a simple equation, 4500d equals to this plus this, 75, 4050, yeah, 45000. So d becomes 451234, 1234, 4500 cancel 100. D is 100 meters. Shown. What about the B part? Okay, we'll have to bring the B part up. The car B starts off at the same time as car A. That means they are traveling side by side. Okay. The two cars arrive at P simultaneously. Okay, so B also reaches here at the same time. Time taken is exactly same. All right. And with the same speed. Okay, so the speed here is also 25 meters per second. Okay. The engine of B produces a driving force 3200 Newton. That means it is weaker than the first one. And the car experiences a constant resistance force of 1200 Newtons. Yeah. 1200 Newton, not, this was joules, that means that was the work done, this is just force, 1200 Newton. Okay, find the mass of B. So we'll use exactly same formula, delta potential energy will still be 0. So let's write it. So work done by the applied force is 3200 times D. Work done against resistance will be 1200 times D, force times distance. Rather, we know the D now. Why I'm using D? So it will be 2 zeros multiplied by 100. Okay, equal to 1200 multiplied by 100. Okay, plus the change in kinetic energy will be little different. Why? Because the mass is different, right? Mass of this particular car B is not given. So, or they are asking it here. So mass. But we know it was 625, right? V square minus U square, U is 0, V is 25, 25 square is this. Okay. So we can bring the numbers to the other side. 3200, 100 minus equal to half of this will be 312.5 m. This is how much? 20 and 4 zeros both of them. So 4 equal to 312.5 m. So now we can find m equal to 21,234 divided by 312.5. Use your calculator and you'll get it. By the time you do this, and I'm also doing it, please like this video, share with your friends, and subscribe to my channel. It will motivate me to make more videos like this for you. Thank you very much. I got 640 kilograms. This is the mass of car B. Okay, are they sparing us out of this? Or find the steady speed which B can maintain when its engine is working at the same rate as it is at P. So when they say steady speed, that means uniform speed, right? And it is going in one direction, so speed velocity is same. When velocity or speed is constant, that means applied force is same as resistive force. Try to understand this. When we had this situation here for car B here, this was 3200, this was 1200, it was more. That's why it accelerated from 0 meters per second to 25 meters per second here. That means we have to reduce this applied force. And how much we have to reduce? We have to reduce up to this, so that there is no acceleration as a result, because MA is, let me write here, MA is applied force minus resistive force. So if both of them are equal, this will be 0, and that's why acceleration will be 0. Acceleration 0 means the speed will be maintained. So if resistive force is 1200 and applied force is also 1200, that means, let me write it formally, applied force is equal to resistive force, which is 1200, right? So now we have to maintain the same speed. So they're asking what is that speed. And now since they are talking about the same rate of working, so work over time, rate of work is actually power, and power is applied force times speed. Okay, they're saying at the same time, when the engine, as it is at P, whatever is the power at P, that's what they're using. So at P, power equal to, applied force was 3200, speed was 25, that is 80,000 watts. So they want 80,000 watts to be maintained, but the speed should be same. So what will be the speed? So we'll use the same formula now. The power is 80,000 for us. But now the applied force has reduced. It has reduced to 1200. So what will be the speed? So the speed will be 80,000 divided by 1200, which is 66.66 meters per second, rounded off to 66.7 meters per second. Okay, the particle starts from O, a point O, and moves in a straight line. The velocity v meter per second of the particle is given like this, where k is a constant. Verify that the particle returns to O when t is 0. When it returns to O, what that means? Return to O. So if this is O, it went somewhere and came back to O, the displacement was 0. So basically we will find displacement equation from velocity and we'll make it equal to 0. To find displacement from velocity equation, we integrate with respect to t. So it will be, let's keep k out of this, 3t square minus 2t cube dt. So s is equal to k and 3t cube over 3 minus 2 to the power 4 over 4 plus c. Okay, and this has to be 0 when time is 2. That means from 0 to 2 we have to show that it is 0. Okay, so k, 3 and 3 cancel, t cube This also cancels. Minus t to the power 4 over 2 plus c from 0 to 2. So k, and we'll substitute 2 now. 2 cube minus 2 to the power 4 over 2 plus c minus k 0 cube 0 to the power 4 over 2 plus c. This is 0, this is 0, this c will cancel with, along with k with this c. So we are left with only this, which is k 8, 16 divided by 2, 8. Yes, k times 0, that is 0 meters. Yes, at 2 seconds, particle returns to the starting point. What is the next part? Next part is this. It is given that acceleration of the particle is minus 13.5 meters per second square for positive value of t at which v is 0. Earlier we equated s equal to 0, so now we have to make v equal to 0. So 0 equal to k 3t square minus 3t cube. So hence find k, total distance travel and total distance travel in the first 2 seconds. Okay, so first we have to find the time when it is v is equal to 0, and then we'll find acceleration for that. Alright, so k cannot be 0, is a constant, so only this is the one. So is it 3t square minus, no, it is 2t cube. So what can we take common in this? We can take common 2t square. If I make this equal to 0, I take 2t square common. Let me write here. 3t square minus 2t cube equal to 0. 2t square taken common out of this. Out of 3, 2 is out. So what should I write inside? 1.5, so that it becomes 3 again. T square is completely out, so nothing left here. Minus 2 is out. Out of t3, t square is out, so just t is left, equal to 0. And now it gives us t square equal to 0, which is t is 0. And this will give us t equal to 1.5 seconds. So velocity was 0 when it started. Velocity is again 0 when the time is 1.5 seconds. They said positive value of t, right? And this is the one. Now we have to find acceleration at this point, and we have to, this was the velocity equation, we have to find acceleration by differentiating the velocity equation, which will be k is there. Because it's a constant, not affected, this will be the differentiation of this will be 60, and this will be minus 6t square. Okay, and this is, they said it is minus 13.5 when time is 1.5 seconds, right? Indirectly, because they said when velocity was 0, and we just found that at 1.5 the velocity is 0. So that's why we substitute here 1.5. 6 times 1.5 minus 6 times 1.5 square equal to negative 13.5. 9 minus 2.25 times 6, 13.5 equal to negative 13.5. This is negative 4.5k equal to negative 13.5. Divide both sides. So k comes out to be 3. This cancels, this becomes positive. 13.5 divided by 4.5 is 3. So they're saying find k and hence find the total distance traveled in first 2 seconds of motion. Okay, so let's try to visualize this again. It started from O. For 1.5 seconds it traveled, stopped. Whenever a velocity becomes 0, that means it turns back. It turns back, and at 2 it came back to this one, because in part A we proved that displacement at t equal to 2 was 0. So are they asking total distance in 2 seconds? That means we have to find only one distance from 0 to 1.5, and same distance was traveled in next 0.5 seconds to reach at O again at 2 seconds, t equal to 2. So we will write t cube minus t to the power 4 over 2. There's no need to write c anymore because it will get cancelled from 0 to 1.5 seconds. And there was 3k outside, right? And we will double it later. So 1.5 first, 1.5 cube minus 1.5 to the power 4 over 2, okay, minus, and this will be 0 cube minus 0 to the power 4 over 2, it is gone. Nothing, even if I put 3 here, it is gone. So this is the one displacement which we can get as an answer. So it will be 0.84375. This is what we get, meters, right? But it is only one-sided distance. We have to double it because it returns also. So it becomes total distance from t equal to 0 to t equal to 2 will be twice this. It will be 2 times 3, 0.84375. And by the time I use my calculator for this, I would request you to subscribe to my channel, like this video, share with your friends, and motivate me to make many more videos like this. I'm going to make many more videos definitely if you subscribe to this channel. What I get here is 5.0625, and if I want to round it off, it will be 5.06 meters. Okay, next, question number 7. Two particles A and B of mass 0.4 kg and 0.2 kg respectively are moving down the same line of greatest slope. Okay, which one is up, which one is down, we don't know. Okay, so let's, for the time being, let's draw 2 points here. One is here and one is here. One is A is 0. Let's write here A is 0.4 kg and B is 0.2 kg. Are moving down the same line of greatest slope. The plane is inclined at 30 degrees to the horizontal, and A is higher up. Okay, they've given here. So this is A, this is B. In the plane, on the plane B, when the particles collide, okay, the speed of A and B are, this has to be faster. So this is moving at 3 meters per second and this is moving at 2 meters per second. Are they moving down? Yes, both are moving down. Okay, so because this is faster, obviously this will collide with B. Find the speed of B immediately after the collision. Okay, so we'll use the conservation of momentum, which says m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So m1, the mass of the first one, let's say A is mass 1 for us. What is mass? 0.4. U is 3 plus m2 0.2 kgs. u2 is 2 meters per second. Same direction, both are positive, okay? And after collision, speed of A is reduced to 2.5. This 2 is very important, okay? Sometimes they say reduced by 2.5. So to confuse you, people in hurry don't read this. So it's 2.5. So 0.4 is the mass, 2.5, m2 we don't know. But we know, what are they saying? plus 0.2, and v2 we have to find out. So this will be 1.2 plus 0.4 equal to 1, no, 1, yes, 1 plus 0.2 v2. So how much do we get here? 1.6 minus 1 equal to 0.2 v2. 0.6 equal to 0.2 v2. So v2 comes out to be 0.6 over 0.2. Okay, that is 3 meters per second. That is the speed with which B moves down. Is it more than 2.5? Yes, it is. They will not again collide. This is 2.5. A is moving at 2.5 after collision. It is moving at 3. That means B will be faster. Just keep that in mind. Alright, what next? After the collision, when B has moved 1.6 meters down, B, they are focusing on B now. So let's say that this is B. Okay, and 1.6 meter down the plane from the point of collision, it hits a barrier. So there is a barrier here. So it will go and hit this, and distance is 1.6 meters. Okay. Greater slope. B hits the barrier 0.4 seconds. So time it takes is 0.4 seconds from collision to this point. Okay, after the collision. And when it hits the barrier, its speed is reduced by can you see, by 90%. That means only 10% of the speed it returns with. Whatever it hits the barrier with, 10% it returns with, 90% is lost. The two particles collide again. Well, we'll talk about that. We'll think about this later because this is becoming complicated. After their previous collision, so they collide again after previous collision. Okay. That means it is not after this. Okay, we'll talk about that. And they then coalesce on impact. Show that B immediately after it hits the barrier is 0.5 meters per second. After it hits the barrier, that means this 10% is 0.5 meters per second. That's what they're trying to say. Hence, find the speed of combined particle immediately after the second collision. Okay, we'll talk about second collision later. First, let's look at this one. So we know the distance here, 1.6 meters. So S is 1.6 meters. Time is 0.4 seconds. We have to find the speed after. That means let's find V before hitting the barrier. So let's say V equal to what? But we know U. For particle B, U, when after collision we got, it was 3 meters per second. Yeah, 3 meters per second. We know U. So V is U plus 80. V we want to find out. U is 3. Time is 0.4 seconds. But problem is acceleration is not known. So let's find acceleration. This was 30 degrees. As far as I remember. Yeah, 30 degrees. So let's say the force is on this particle here. Its mass is 0.2 kg. So it becomes 2 Newton this way. 2 sine 30 this way. And there is no resistance because they said that the plane is smooth. Somewhere, yeah, smooth plane. Yeah, so there is no resistance. So this is the only force. So we know that MA equal to applied force minus resistive force. Mass is 0.2. Acceleration we want to find. Applied force is 2 sine 30. Sine 30 is half. And resistive force is nothing because there is no other force than friction and it is smooth, so no friction. So A becomes 1 divided by 0.2, which is 5 meters per second square. So this is 5. So V equal to 3 plus 5 times 0.4 will be 2, 5 meters per second. Now, after hitting barrier, it will be 10%, 10% of 5, which is 0.5 meters per second. We showed it. Good. Let's talk about the second one. Hence, find the speed of the combined particle immediately after the second collision. Okay, after second collision. So before second collision, we should know this, but again we will use conservation of momentum and same formula, but in this case both masses have become same, so we will write this way: m1 plus m2v. They will be combined. Okay, so our first mass was particle A, whose mass was 0.4 kg. Yeah. Speed of u1 was 2.5 after first collision. If you remember part A, they said after collision it moves at 2.5 meters per second here, but it won't maintain this because it is going down. There is a force downwards which is trying to take it down. So which will be let's say this one. Yeah, if particle's mass is 0.4, it is just like this, what I did here. So it will again be going down by an acceleration of 5 meters per second square. So it will not be 2.5 anymore. So let's find what speed it will reach there. So v equal to u plus at. Before collision, what will be the speed of the particle A? V equal to u. We know that after collision it was at 2.5. Acceleration will be 5. Yeah, it is constant. It is independent of mass. And time for this is 0.44 seconds, right? After the collision, 0.44 seconds after their previous collision. So by the time it went, the particle B went down and hit barrier and went back, it kept on coming down with, so time used is this one. So V equal to 2.5 plus 2.2, which is 4.7 meters per second. This will be used for particle A. Particle B, 0.2 kg, but its speed will also be different now. We know after colliding it was going up at 0.5 meter seconds upwards. Okay, so everything I'm calculating now is upwards. U is 0.5. Acceleration will be downwards, minus 5 meters per second, the opposite of what was here, because it is trying to go up, but by the same calculation the acceleration is still downwards, so it will become negative 5 meters per second square. Time is not 0.448 anymore because it took 0.4 seconds to come down. See, it took 0.4 seconds to come down, and then it is going up. That means this 0.4 will be removed from 0.44 seconds they are saying after collision. So time will be 0.44 minus 0.4 seconds. So now we can find the speed with which it will hit A, particle B. Okay, the particle B hits A with this speed, u plus at. V equal to 0.5. We are still talking about upwards, okay? And this will be plus, the deceleration will be there, and t is 0.04 equal to 0.5 plus, not plus, minus 0.2, which is 0.3 meters per second. It slowed down from 0.5 to further 0.3 meters per second, and this is what we are going to use here. But this speed is opposite to this one, so it will be minus 0.3 equal to 0.4 plus 0.2 V. So it will be how much? 1.88 minus 0.06 equal to 0.6 V. 1.82 equal to 0.6 V, and V comes out to be 1.82 divided by 0.6, which is almost 3.03 meters per second. This is the speed with which they are moving. This concludes our solution of this video. Thank you very much for watching. Please don't forget to subscribe to this channel and spread out the word with your friends. Thank you.